So today we're going to take a look at how to factor completely using synthetic division. Our first example, we are given a zero of the function. We are going to use synthetic division, and then we'll finish factoring completely after that. Notice the cubic function that we are given does not factor by grouping. Our first two terms, we could factor out an x squared, leaving us with x minus 2. However, the second two terms do not have a JCF. We could factor out a negative 1, leaving us with 11x minus 12. But what's left inside the grouping symbols are not identical, so we could not continue to factor, which is why we'll use our synthetic division and the given 0 to get this factored completely. So we'll set up our synthetic division. We will put those values inside the box, the coefficient of x cubed, the coefficient of x squared, the coefficient of x, and our constant. This time, because that x equals 1 is not in a binomial, 1 is the factor, so we leave it alone and we put the positive 1 on the outside. We do not make it opposite when we're given the 0. So we drop our 1, multiply by 1, add the negative 2 plus 1, multiply by 1, add our negative 11 and negative 1, multiply by 1, and add. Because we got 0, we have confirmed the fact that x equals 1 is a 0 of this function. So we would have x minus 1. That's where it goes opposite when we put it back into the binomial. This is what we divided by. And then our result was the 1x squared minus 1x minus 12. Remember, drop a power when you write your answer after synthetic division. Now we will check to see if we can continue factoring our result using methods we already know. It's a quadratic, that x squared minus x minus 12. The coefficient of x squared is 1, so we should be able to use our t-chart to factor this one. So we're thinking what multiplies to negative 12, the constant, and adds to negative 1, the coefficient of x. I'm coming up with negative 4 times 3, and negative 4 plus 3 is negative 1 as well. So when we continue to factor this, we keep that first factor, x minus 1, and then we factor this into x minus 4, x plus 3, based on our t-chart. And then we can finish finding the zeros. Remember, zeros occur where the function equals 0. They're also known as roots or x-intercepts. So to finish solving this, we would set each piece equal to 0. And solve for x. So our zeros are 1, 4, and negative 3. And because we're linking this to the graph, we will write them as ordered pairs. So we have 1, 0, 4, 0, and negative 3, 0 for the roots or the zeros or the x-intercepts of this function. We'll take a look at one more, very similar to the last one. We are given a 0 of the function, so we'll set up our synthetic division. The coefficient of x cubed, the coefficient of x squared, the coefficient of x, and our constant. And we are dividing by the negative 5. Again, x equals negative 5, so we do not make it opposite. Bring down our 2, multiply by negative 5, add, multiply by negative 5, add, and multiply by negative 5. Our result is 0, so that means the remainder is 0, so we did get a factor of our function, x plus 5. When we put that back into the binomial with x, that's where it becomes opposite. Writing our result, dropping a power, we have 2x squared minus 5x plus 2 equals 0, because we're going to be finding all of the zeros of our function. This time we have a leading coefficient of 2 instead of 1, so we would have to use the AC method to finish factoring this. So we'll multiply that coefficient of x squared, or the 2, by the constant of 2, figure out what multiplies to 4, and adds to that middle term of negative 5. I'm coming up with negative 4 times negative 1, and negative 4 plus negative 1. Keeping that x plus 5 And then setting this up to factor by grouping, we're going to split that middle term. So our first term of 2x squared stays the same. We use the -4 and -1 to split up that -5. We leave our constant the same. And then when we start to factor by grouping, for the first two terms, we can pull out a 2x, leaving us with x minus 2. Our second two terms, we can factor out a -1, leaving us with x minus 2. To finish factoring by grouping, we have that common factor of x minus 2 that we'll factor out, leaving us from the first term with that 2x, and from the second term with a -1. Setting each piece equal to 0 now that we have it completely factored. And then solving, we get that first 0 that we were already given, -5. We get a 0 of 2. Here we'll have to add 1 to both sides and then divide by 2. We have a 0 of 1/2. Writing these as ordered pairs for our x-intercepts, we have -5, 0, 2, 0, and 1/2, 0. And finally, you have a U-try question. You are given 1 0 of this function, and then this one you will also have to use the AC method to factor completely.